On the 25th of March 2025, Bambu Lab released the H2D, their new flagship 3D printer that also does some other stuff. Today I'm going to be doing what I do best, and that's tear down this entire machine to pretty much every nut and bolt, giving it a good, thorough inspection, and as we go along, I'll point out things that I find particularly interesting, as well as highlighting any build quality or maintenance issues. Bambu Labs sent me this machine in order to do this teardown, but I've not been paid to say anything specific or avoid any topics. The full disclosure notes are in the description below. If you'd like to support my work, why not head over to vector3d.shop and check out Electropie, a buck converter and cooling fan designed to fit directly onto a Pi in order to power it and other 5V devices within your 3D printers. If DIY 3D printers are not your thing, check out Kali Lantern and Kali Flower, our easy-to-use, high-quality calculators designed to improve your 3D printer's accuracy for all your prints. My name's Adam, welcome to Vector3D. This is the teardown of the Bambu Labs H2D. As you've already seen, I started by removing a number of screws around the rear panel in order to remove that first. The foam pieces attached to the back seem to be there for a combination of air filtration, sound dampening, and sealing, something which we'll continue to see throughout the disassembly. After removing the top panel, I was looking around for screws on how to release these big grey panels on the sides. I couldn't find them on my own though, so I did have to dip into the instructions, something I very rarely do for these disassembly teardowns, but with that additional help, I identified the screws which needed to be removed. On the left side panel, there's also a screw underneath the fan, so the fan had to come out too. 2 screws secure this whole assembly to the frame, with 2 isolation mounts at the top. The fan is also secured to the rest of the housing using 4 more isolation mounts. I removed that 1 screw behind the fan, and then moved on to the 4 at the front, which are just tucked behind these rubber flaps. And rubber was a great choice here. It's kind of perforated around the whole area, allowing you to create this flap and get to the screw, and obviously the use of foam would have probably kind of destroyed it in the process, and then it would have looked horrible, so great choice. I then struggled for a little while trying to get the panels off. They're kind of held on via some sort of clipping system to kind of round the back and down the front, but for some reason there was this part in the middle which I searched around for ages to try and work out if I was going to break it the harder I pulled, or if that was the intended mechanism. Instead of risking damage, I tried the other side. I removed the clips down the back, and then the ones around the top, and the side, and that one just basically fell off, which is clearly the way that it's meant to work. With the application of some additional force, the other panel did eventually come off. And you can see here at the top where I'm pointing, this is the extra sticky bit that is just seems to be in the wrong place. You might have wondered at some point how the printer will know the difference between the glass panels being fitted and the green plastic ones for laser cutting. Well, this is it. There's a Hall effect sensor and magnets attached to the green panels. So that means the printer will know if the magnet, aka green panel, is fitted, versus the glass panels with no magnet. Much like their other printers, the H2D's multi-material system revolves around purging material, so around the back we do have this purge waste chute, as well as the nozzle brush nozzle cleaner combination thing. Now, since that part moves, you might have thought that there's little servos in it to get it to move around, but actually you just move the tool head to the right position and it presses on these small yellow levers at the back, which deploys the various scrapers, nozzle, brush, whatever, into the right position to actually affect the nozzle. I think it's a simple yet effective mechanism, and because it's built into this very easy module, you can replace it without any difficulty. After having a look around the printer, I identified that it seems to be made from 3 sub-assemblies, a top, middle, and bottom. The top part is made of plastic and houses some of the electronics, wiring, lighting, and stuff like that. The middle part is the CoreXY Gantry, which is this fully die-cast aluminium gantry part with all the motion components. And then the bottom part is basically everything below that kind of motion gantry, including the bed, the rest of the frame, and the base. So what you can see me trying to do here is identify all the screws that secure that top plastic rim to the die-cast part below it. After identifying the screws, I also found that these little mechanisms on the inside, which deploy to allow for cutting of the filament, also attach this top ring to the die-cast frame. There's one of these attached to each side, and there's no electronics or sensors in them, they're just deployed by the motion of the gantry. So as the gantry moves into position, the little arm is deployed, allowing the tool head to move into it, cutting the filament. Because there's a number of wires connecting this top section to other parts, we do have to remove some of the wiring. This board that you're seeing here is actually one of the two main control boards in the printer. This is the AP board, or Application Processing Board, and appears to be responsible for lots of the graphics processing, so all the webcams and the AI detection kind of systems. Around the back, we have this cable which goes down to one of the internal webcams. A slight over-reliance on sticky tape here, I think. With that cable removed, as you can see, we start to get some movement in the top section. With the tool heads, drag chain, and cables attached to this top area too, we do need to make sure that those are fully detached before we remove the top plastic section from the rest of the printer. This was actually really difficult to do. It only looks like it took me 20 seconds in the video, but this was a few minutes of trying to work out how this thing clips in. We do also have a lot of very small cables we have to deal with because these all go up to the top section for things like the AP board, Hall effect sensors, tool head, etc. While most of the connectors used here are very similar, there are a few variants for different purposes. They're not too bad, they do lock in, which is good for the most part, although disappointingly some were frustrating to actually pull out. They are very small and your fingers are just not very good at pushing the very tiny levers to unlock the clips. With the cables all disconnected from that control board, I was then able to fish them out and sort of release them so the top section could hopefully be removed. There was this one more connector, again for another Hall effect sensor for the door. I kept the sticky tape there just to make sure I knew where it belonged and I could put it back afterwards. This was the last cable, and then the whole top just lifted off carefully, hoping I don't crush or destroy any of the tiny cables in the process. Taking a closer look at this top section, I identified that there were these weird gaps within the top foam, so I wanted to cut out a little square to see what was underneath. In this first one, I didn't find anything, but in another, there was actually a sensor, another Hall effect sensor, with obviously more magnets for sensing, and I believe this one is there to ensure that the top glass panel is positioned correctly. This was another bit I had a look at the instructions for because I didn't want to damage the front panel of the printer. First, there's a screw just below this webcam, and then you lift the two edges and can remove the whole front fascia. This bit was kind of annoying, and I'd probably have preferred more screws and things here just so it's easier to do, but with a little bit of a click it does come off. Just be careful of the ribbon cable. Removing the LCD panel from this single hinge with two screws was pretty easy to do. It came out without any trouble. Despite my efforts to open this up and take a closer look, there wasn't really anything to take a closer look at. So I probably wouldn't bother opening this up again. There's not really anything in there you can see. Next, I had to play around with this vent at the front to try and work out how to take it off even. There's no installation or replacement instructions for this, so presumably you won't need to do it. It took me absolutely ages to work out how I can get access to under the vent because there's screws pointing up towards it. Eventually, I managed to get a screwdriver in there, remove the mount, and the whole thing sort of came out together. Again, not very easy to do, but shouldn't need replacing. The motor used here is just a simple DC motor with a gearbox assembly attached to it. This seems to be one of those low-cost hobby motors. You can actually buy these individually on their own from Bambu for your own projects. Removing the wires first, next it was time to take the AP board off of its mount. So there's 4 screws to do that, and I took all the wires out first. There's just 4 screws holding it in, and it's really easy to remove. This should be doable without doing this much assembly of the printer, so if it does need replacing, I don't think it's going to be as huge a job as it looks like from the way I'm doing it. Lastly, remember the Wi-Fi antenna is also attached here, and you can't see it without starting to remove the board, so don't yank it out. Make sure you remove that first. This is a full view of the AP board, and I've labelled a number of the locations that I remember so you have an idea of what this board is actually doing. Here I'm removing the bird's eye view camera. This is used to assist in orientation and positioning of parts for the laser cutting or cutting module. It's not even present on the 3D printer only version. The USB PCB is just plain and plugs directly into the AP board. The LED lights are a stickered strip with a diffuser over the top. This is another bit that took me blooming ages to work out. There's a big rubber block in here, and that houses the optical sensor for the fire detection. The way this works is that these sensors detect a certain wavelength of presumably infrared light emitted by fires within the enclosure. On the opposite side to the USB port, we have the button, which is just surrounded by LEDs in order to make it illuminated. Very nice. These cable clips, which I use to hold all these small cables in and stop them getting pinched, are really good at holding the cables in. The downside is I couldn't get a cable out without cutting the clip or damaging the cable. Obviously, you don't want to damage the cable, so you cut the clip and then it's not really any use anymore. Next, I started to remove all the screws that are at the top of these sheet metal parts around the four corners, because it looked like these are what holds in the die-cast frame which forms the gantry. So I thought, remove all of those, pull the gantry out, job's a good one. Except it didn't really go anywhere, even after removing all the screws. I should have looked closer, but at this point I was a bit confused, so I did some unforgivable things. Yeah, I really wish I'd never done either of those. Anyway, I then realised that these two compartments at the back, because of some of the extra screws I'd removed, are now starting to move, so I can get those out, but in order to do that, I also need to remove the bed, so onto the bed. This part of the process, I'd say, didn't go particularly well. You'll see why as we go through the process. These 4 screws on the top of the bed actually adjust the tension, so these are the spring-loaded ones, and the black ones, which I'm removing around the side, connect the top movable part to the base, which is actually connected to the motion system. The idea here is that you adjust the springs to get the bed as level as possible, and then permanently lock it in place using these screws around the side. However, I thought by removing these, I'd be able to remove the top section from the bottom section and then remove the bottom section, because I didn't see a way to get to any screws that would allow me to do this any other way. I found the 2 at the back first. These were actually quite visible, but I didn't bother undoing them until I thought I could do all of the ones that looked similar. I even found some screws underneath. I was adamant that I'd be able to just keep removing screws and the bed would come apart. And I don't think I've ever been more wrong in how I try to disassemble something. Still adamant, 2 more screws at the back of the bed. Again, basically wrecking the calibration setup of the bed in the process. I finally found how you get to the screws. There's 2 rubber bits at the edge of the bed. You pull these up and you can put the screwdriver down to access the 2 screws, removing the whole bed assembly from the motion system. To remove the bed though, obviously I need to disconnect the wires, and for that I need more access. To get more access, I need to remove this huge lump here. This is, as far as I can tell, the air assist used for the laser module. So not used in a 3D printer version, and I believe not included when you buy the 3D printer version. It's just for the laser cutting. Here you can see another good example of how they address noise and vibration in this machine. This module is responsible for the filament control, and they've added a really nice spring system here, so it makes getting to the PTFE tube connectors much easier than on the X1 carbon version, which of course was just a single filament, but it's the same kind of system. Next, I removed the AC cover, which is a really complicated injection molded part, which looks way more complicated than I think it needs to be. This kind of suggests to me that either they'd sort of taken stuff out of the design, or there'll be future designs that utilize more of the features here. These large spade terminals for the high voltage connections do use a latching system, so you'll need to depress the latch in order to remove the connector. And then further down, again, the mains input connection to that mains power board. This braided cable here is the one for the bed, and you can see the mains connectors as well as earth and the LED cable. Fishing that through the panel, I can then put that through to the front, and that'll allow me to remove the bed. From the front, the bed simply just lifts off and the cable should kind of slide out, although because it's obviously got connectors and stuff on it, they do just tend to get caught on everything. With the bed removed, I can now take it apart and show you how it's constructed. Of course, we have these screws in the top for tramming, and the ones in the side, which is sort of locking screws, to hold the tramming in place so it can't be adjusted. At the back, we have the inductive sensor, which does the nozzle offset calibration. You can't really see much when taking it apart. It's kind of potted, but I presume under that bit of resin is the sensor. Next to the inductive probe, we also have the nozzle scraping area and what seems to be some kind of calibration pad. This connector at the front is for the LED status bar, and this grey cover is where all the connections connect for the bed. This large black hoop is the main frame of the bed and is pressed from sheet steel. You can see it provides most of the structural rigidity for the bed. This is the LED bar. It can be replaced as a module, but it's not very easy to open. There's no screws or anything, just these melted plastic posts. Under this cover, we can see the mains connections. It all looks a little bit messy under here, which isn't super impressive. but functionally fine, although I did break my screwdriver. What the fuck? So yes, that's not great. It just sort of snapped off in the screw. Again, I don't like people that use red Loctite because you don't even know until after you try opening it. As you can see, the bed construction itself, in terms of the heating module, is basically the same as the A1. With the bed removed, we can now move on to the side compartments. One of them contains the MP board and main control board, whilst the other has the power supply, vents and filters. Removing just a couple of screws and connectors, just unrouting all the wires, we managed to get everything out without too much of a problem. I'm not sure this is the intended order of operations. Half of me thinks it is and half of me thinks it isn't. This is one of the two control boards. This is the MC board or motion controller board, and that's why all of the motion control stuff is connected here. The two MCUs for this are on the back. In the side of the compartment, we have the AC board, and this is responsible for power distribution to both the heated chamber and heated bed. The third and final PCB in this compartment is the expansion board, and I think this has some missing components which could potentially be part of an Ethernet upgrade for an enterprise version, much like they do with the X1E. Finally, after getting all that sorted, with a little bit more of muscular persuasion, which I regret doing as always, I finally managed to get the gantry removed from the rest of the printer, sliding the rods out because they're attached to the gantry. What made this disassembly section so difficult is that there's pins protruding from the sheet metal parts into the gantry. I didn't notice this at the time, and while I think about it, if I looked closer, I probably could have noticed, but evidently I didn't. So if you knew that, it would be probably a little bit easier to do. Now it's time to get into the tool head. Without doubt, one of the most impressive, most complex, most crazy tool heads I've ever seen on any 3D printer. The amount of stuff in here, you are not going to believe. With the clear outer cover taken off, we start removing a number of screws around this lower section on the front panel. It's a bit of a fiddle to remove, but once you manage to get it off, you're rewarded with seeing this nice little spring mechanism which retains the precision in the filament path as the left-hand hot end moves up and down. A couple more screws and a ribbon cable and we can move this front cover, which on its own has multiple sensors, multiple bearings, detemp pins, magnets and everything in this one tiny little piece. Next, we remove the two filament cutting arms. Of course, they're not symmetrical because of the different filament motion systems on each side. Then we move on to the two extruder arms, of which, of course, have more sensors attached. These are the sensors which trigger on the magnets, which are on the front piece, which I just showed you. These tell the printer which arm is currently engaged. I also think the cables here are quite cool because they're actually more like flexible and rigid PCBs combined into a single part. So you get something that's rigid, which you can screw, but then something flexible to move around and wiggle how you need. Now we can remove the extruder gear, which is absolutely huge among us. And then I just started removing extra screws from, I think, part of the filament guide path. This screw is part of the side pod, which is part of the duct cooling system. So just a plastic empty piece. From here, I started removing a bunch of screws which hold what I now know to be the extruder plate. On my first attempt, I couldn't quite get it off because there's a bunch of ribbon cables that attach round the back. So I attacked from another direction and started at these screws on the side, which I quickly realized are just to mount the belts to the carriage. A very smart system here where you don't have to readjust the belts every time you attach them. Heading around the back now, you can start to see how electronically complex this toolhead assembly is. You can see here the first of the two stacked PCBs. These ribbon cables attach to things like the various motors as well as the board-to-board connections. This connector here with the larger plug is for one of the two hot ends, where the other hot end uses the same connection. And then once those are removed, we can detach the screws which hold the two PCBs together. And from there, you'll see the two posts which presumably connect power from board to board. And in addition, there's obviously now a bunch more ribbon cables as well. With those ribbon cables all carefully removed as well, including this little sneaky one on the side, which I didn't see initially, we can now start to remove the second PCB. And this is one that starts to get a little bit weird. Yeah, sorry about the hands, but this is where the USB connects with this extra little wrapped piece around it. I'm not really sure why. And then this kind of dodgy wiring situation on the back. Yeah, I'm really just not that impressed by this weird soldering job on the back. It looks like it was meant to be a connector and the connector kept failing, so they just soldered it on. And honestly, I think I'd just grown to expect better from Bambu Labs, to be honest. Moving on, this is the magnetic alignment plate, which makes sure that the paddle, which blocks the nozzles, sits in the correct position as it moves between them. And behind that, we have the nozzle camera, which of course is just a couple of screws and a ribbon cable back to the main PCB. And now we can actually remove the extruder plate because we removed the ribbon cables, which were of course attached to the PCB. Again, sorry about my arm being in the way. I didn't realize until afterwards. Now that we got this removed though, let's take a look at the motors that are attached to it. Yes, there are two. The first is this servo motor, which is used as the extruder motor. It's a custom one made by Bambu Labs specifically for this machine. After removing a bunch of screws, I tried to separate these two parts and it was very difficult and I couldn't work out why. I gave it a twist and then realized how badly I fucked up. You see, these wires here go through these slots in the PCB and solder to these pads here. But I didn't really realize that because I wasn't thinking straight at the time. And by removing the PCB from the coils without first desoldering the wires, I snapped the wires, killing the motor. I did eventually manage to actually solder the wires back on when I did the reassembly, but don't ever do this. Just don't bother disassembling this motor. You're not going to help yourself in any way. Let's move on to the other motor and see if I can do that without breaking it. A couple of screws release the cover, and a pair of tweezers easily prise off the gears and bearings. 3 screws hold the motor in place, and there we have it. We can see this has a rotating part on the back and then a long cylindrical body. I decided to open it up to take a look inside, and we find that this long body is actually a gearbox. To me, this looks like a planetary gearbox, of course designed to significantly increase the torque while reducing the speed. These 4 screws here are the ones which attach the tool head to the carriage, and unfortunately we have another screw issue here. One of them looks like it was significantly over-torqued and has damaged the head of the screw. A standard hex shape didn't work, but luckily these modified Vera ones just about managed to extract it. From there, I decided to remove the 2 Hotend mounts. Of course, the left one is the sliding one and the right one is stationary. Weirdly, these are slightly different on each side. I'm not totally sure why. There's a small heat shield here which protects the plastic from the hot end temperature. It's important to remove this at this point too. This was another occasion where I overdid the removal of screws because I'm actually now undoing the casing for the 3rd motor. I didn't realize it at the time because it's quite difficult to tell what's going on. And then I found these ones which basically attach the kind of toolhead carriage to this outer grey casing, and that's what finally allowed me to get everything removed from one another. Quite difficult to find those screws as they're quite deep within the assembly. This part now is the inside of the 3rd motor. As you can see, a few gears and a rotating arm. This is what the motor assembly looks like from the outside. On the right hand side you can see the nozzle blocker paddle thing, and on the left the short silver arm with the bearing on the end is what forces the hot end carriage bit up and down. Let's have a quick look round all the various bits you can see here, as obviously during the disassembly I do it in a kind of chaotic order and it's quite difficult to tell what's going on. So, of course, around the front we have our 2 nozzle assemblies, our 2 hot ends at the front with the heaters and thermistors behind them. The left one, of course, is attached to a carriage, allowing it to move up and down, and the one on the right is the static one with a sensor at the top. To the sides of the nozzles / hot ends, we have these 2 kind of empty plastic parts, and these are part of the ducting system for the part cooling. Around to the side we have one of the sensors. You can see the camera here and illumination behind it. From below we have the nozzle blocker and then the magnetic alignment assembly behind that. Behind that we have a nozzle camera. Going around the back we have a motor and the motor housing for the mechanism which does the nozzle motion as well as the nozzle brush movement, which I'll show you in a second. Around this side, this is the hot end side that moves up and down. We have a copper coil in this part at the back, and then at the bottom we have a magnet, and that's what holds this hot end assembly down, mostly, I think. So let me run you through the actual hot end motion system. To begin with, I'll just rotate it, and I'll show it to you, and then I'll try and walk you through it on the reverse journey. So you can see 2 things happen. This nozzle assembly moves up and down, and the blocker pad moves from one side to the other. I'll now show you in reverse what it looks like as I control the motor slowly. So the first thing you'll notice is that the nozzle blocker starts to move away, and then the nozzle will begin to move down into its new position. You can see as the nozzle blocker starts to move to the side,
it's at now this weird jointy angle. If this carries across in that plane of motion, it's going to get stuck on the nozzle in some weird janky angle, and you'll see in a second why I think that third magnet is placed there. There we go. It changes the orientation of the blocker to be just right, so that as it comes into land on the second nozzle, the magnet holds into place and it's nice and flat. So 2 items, both controlled by 1 motor, allowing for switching of nozzles.
With the tool head fully removed and disassembled, it was time to also then remove the gantry, which is this beam across the center with the linear rail attached to it. You can see the tool head exterior is still surrounding it because you can't remove it for some reason without sliding it off the end. There's actually quite a few screws holding this in, 4 at each end, and you can't like push it at the end, so you have to kind of twist it to get it out. Doesn't damage anything, it's just the way that it works. With the gantry removed from the motion system, I was able to slide off the toolhead exterior. It turns out it's quite a bit heavier than I expected, although, stupidly, I forgot to weigh it. Sorry about that. Next up, I wanted to take a look at the idler pins, because previously I think these would be glued in or something, so these ones are a little bit different. They're kind of like screws. In fact, they're basically screws. They're basically shoulder bolts, but some of them don't have a head. It's literally just a pin with a thread at the base. They're nice and thick. They should be durable, they're precision made, and they're easy to replace. So it should be possible to remove or replace any of these idlers. Next, I turn my attention to the linear rods, which at first looked promising because they were clearly held in with screws. So I started to remove the screws, and for some reason, it didn't come out. After applying a little bit of force, I started to realize why. They had in fact also been glued in. While I wouldn't necessarily expect these massive hardened steel rods to need replacing anytime soon, you do still have to remove them if you want to replace the linear bearings. Maybe if the glue stays on the steel rod and you just place it back in, everything's going to be fine. But it just seems an odd decision to not go with a better solution than just gluing them. Moving on to the AB or XY stepper motors, I think these were also a bit of a sticking point in the X1 Carbon and P series, as there was some issue with replacing them due to, I think, they were glued in. Here we go, this is the motors for the H2D, and from what I can see, they're pretty much fully replaceable. Whilst you can't specifically replace the actual pulley itself because that is kind of forced onto the shaft of the stepper motor, the entire stepper motor assembly can be fairly easily removed and replaced if needed. Unlike the straight pins for the idlers on the aluminium gantry, the ones at the XY gantry ends are threaded into plastic and do have a head, but overall just pretty similar. Lastly, we have the linear bearings, which are held in with 1 screw and slide out very easily in their steel sheet metal casing. So on their own, easy to remove and replace, but you do still have to take off the linear shaft in order to get to this point, so not so easy. While I'm disassembling the whole lead screws and base and stuff, let's run through my summary on the rest of the printer. Starting with build quality, overall I'd say very good. There are definitely some questionable areas, but overall not that many, and I wouldn't say too severe. There's certainly a lot more good than there are bad things. When it comes to repairability, this is something that was quite heavily criticized on some of their previous machines due to a number of parts being glued in and unreplaceable. In this case, while I can't speak to the repairability of every single part, pretty much everything was able to be removed and replaced just by redoing screws. One thing that really did impress me on this machine is the toolhead. The amount of complexity in that toolhead is really quite phenomenal. Like, that assembly, I'd say, is more than twice as complex as most 3D printers in their entirety. The number of mating parts, very small wires, assembly, complexity, screws and tooling and all these kinds of things that go into making such a densely packed and high performance toolhead, it's really pretty cool. One thing that did regularly disappoint me is the use of Loctite. There are typically 2 colours, blue, which is not permanent, and red, which is very permanent. Now, the red Loctite used didn't seem to be fully permanent, as many of the screws with red Loctite I was able to remove without too much trouble. But I would prefer universally use of blue Loctite. I don't think anything on this printer needs to be so permanent that you can never remove it, which would pretty much be the case with red Loctite. The other thing that bothered me about it was that the screws were kind of mushy. They were not maybe the best quality screws, and therefore you then combine the high torque requirement with the kind of mushy screws, and the head ends up getting stuck on the screw from the deformation of the head of the screw. For doing the disassembly that you've seen in this video, I only occasionally looked at their guides and maintenance manuals when I needed a little bit of help. However, since doing that work, I have had a good look through them to see how good they are. I'm happy to report that I think they're reasonably good. While I didn't follow them, so I've not tested every single detail, I think they do show you at least how to replace a lot of different parts of the machine. The only area which I think could do with improvement is some of the text. It's a bit confusing as to what it's trying to say. The fix a screw doesn't mean anything. The final observation I want to share is that there seems to be excessive wear on the belt in my printer. I noticed some black particles resting around the idlers. These are presumably part of the belts, which is typically from when the pulleys are not fully aligned. The belt sinks to one side, rubs a lot against one edge of the pulley, and basically disintegrates, leaving the black particles of rubber around the idler. That's it for today. Don't forget to check out vector3d.shop for Kali Lantern, Cauliflower, and Electropie, plus lots of other things. I'm going to go and find out where these screws go, and I'll see you in the next one.